Hello everyone, this is Prashanth. Let's continue with the last lecture here. We are in IoT question bank discussion on various topics. So in the last lecture, just I have completed question bank discussion on different sensors like analog to digital converters, digital to analog converters, and voltage sensors. Based on this, just we have some question bank questions. So we discussed in the last class. So now we move entering into the another question bank discussion on another topic, that is USB sensors and embedded sensors. Let's start with the first USB sensors. What is embedded sensor? What is the objective? What are the outcomes? What are the objectives of embedded sensors in IoT? What are the outcomes of embedded sensors in IoT? So here, USB sensors and embedded sensors very essential. It can play very essential role to build IoT real-time projects. What are the objectives? The objectives of USB sensors: gather data from the environment for monitoring control purpose. Examples include sensors in greenhouses, pressure sensors in water systems, or light sensors for smart lighting systems. That is the objective. And outcomes: it can provide the real-time data for analysis and automation. This data can be used to optimize process, improve efficiency, and gain insight into environmental conditions. So these are the objectives and outcomes of USB sensors used to develop the IoT real-time projects. And coming to the embedded sensors in IoT, here objectives and outcomes. What are the objectives? It collect data in a particular device performance, internal working and surroundings environment. So this data can be used for various purposes such as condition monitoring, predictive maintenance, or user experience optimization. So condition monitoring, predictive maintenance, or user experience optimization. So these are the three main objectives of embedded systems in IoT. And what are the outcomes? So here it can enable the remote monitoring and control of devices, improve device reliability and lifespan, and personalized user experiences based on sensor data. So these are the objectives and outcomes of USB sensors and embedded sensors used in IoT. And what are the outcome ultrasonic sensors in IoT? Along with USB and embedded sensor, we have one more sensor types here, that are the ultrasonic sensors in IoT. What are the objective and outcomes here? The detect objects, measure a distance, and navigate surroundings. So this is useful in applications like smart robots, autonomous vehicles, and obstacle avoidance system. Obstacle avoidance systems. So these are the main objectives of ultrasonic sensors in IoT. And outcomes: improve safety, automation in various IoT applications. Ultrasonic sensor can be used to tasks like object recognition, and path planning and collision avoidance. So these are the main objective and outcomes of ultrasonic sensors in IoT. So here USB sensors, along with understanding of some USB sensors here. While USB sensors are not the most common type of sensors used in IoT applications due to their inherent need for a wide connection, they can still be useful in certain scenarios like breakdown of their application, and why the options might be preferable. So here these are some points to understand the USB sensors, like directly host computer microcontroller board. So it is a universal USB interface. Just you can provide a digital output signals that the host device can read and interpret the data. So they come in various types. and measuring a range of environmental parameters like temperature, humidity, and pressure. So these are the some understanding points of USB sensors here, and applications of USB sensors in IoT. So here rapid prototyping and development, uh, rapid prototyping and development, and logging, data logging and monitoring, and educational use cases. So here these are the three main types of applications of USB sensors in IoT. Rapid prototyping and development. During the development phase of an IoT project, the USB sensors offer a quick and convenient way to connect the sensor to a computer for testing and data acquisition. And in terms of logging and monitoring, so the USB sensors can be used for a simple data logging applications where collected environmental data is stored on the connected computer for analysis. The last one, educational use case for educational purpose also, learning about the sensors and IoT principles. The USB sensors for use for user friendly way to interface with sensors and visualize sensor data in a computer. So these are some main applications of USB sensors in IoT. So next, what are the limitations of USB sensors in IoT? So here connection, wide connection, and limited mobility, and power consumption. In terms of limitations, we have here wide connection. So there is almost today days we are using almost wireless devices to perform our task daily. So there is the wide nature of USB sensors limit their placement flexibility compared to wireless sensors that can transmit data without the wires, and limited mobility. So here for applications requiring sensors to be placed on in remote or hard to reach locations, USB sensors become impractical due to the cable length constraints and power consumption. So while some USB sensors are low power and they still require a wide connection to power USB, they limited their suitability for low battery power IoT device. So these are some limitations here, and alternative to USB sensors in IoT. So when we we fail to use USB sensors, in the place of USB sensor just we use another sensor, that is wireless sensors, and microcontroller shield. Just we use in place of these two the alternatives for USB sensor in wireless sensor and microcontroller shield. For most IoT applications, wireless sensor using Bluetooth or Wi-Fi or cellular communication offer more flexibility and scalability. They can be battery powered and placed in various locations without needing a direct personal connection. And microcontroller shield also one of the alternative to use a USB sensor in IoT. Some microcontrollers have a dedicated shield to add on boards that integrate various sensors, eliminating the need for separate USB sensors and simplifying conditions. And when to consider USB sensor, we have three considerations here: rapid prototyping and testing during the development of stack, that is first consideration, and educational purpose. Some educational purpose also, just we use USB sensor applications where a computer is always nearby to provide power and data collection. So these are the three considered for consideration of using USB sensor. And in conclusion, while USB sensors have a niche role in IoT development and specific use cases, wireless sensor options generally offer more advantages for deployed IoT applications due to their flexibility, scalability, and suitability for battery powered sensor. So here flexibility, scalability, and suitability. So in order to improve these three terms, just we use USB sensors in IoT. And next, embedded sensors. So what are the main role of embedded sensors in IoT. They act as eyes and ear, sometimes even the nose of the IoT device. So here the main significance of embedded sensors in IoT, very very important or essential part. Just it is IoT device constantly monitoring and measuring the physical world around them. Here a deep dive into how they work and significance of IoT. What are the embedded sensors? Like traditional sensor that might be connected to a computer via USB, and the embedded sensors are minimized and integrated directly into the IoT device. So this is about embedded sensors. So here the uh, some of the sensors here. They come in a wide variety of each designated to direct measure a specific physical phenomena. Common types of included here: temperature sensor and pressure sensor, humidity sensor, light sensor, motion sensor, gas sensor, and these are the main some kinds of embedded sensors here. Temperature, it is thermistor, thermocouples. Pressure sensor, a piezoelectric material, it is capacitive, and resistive humidity sensor based on the resistive light sensor, photodiodes, and motion sensor used in accelerometers, gyroscopes, gas sensor, electrochemical, metal oxide semiconductor, like that. Just we use different based on the requirement. Just we may use which sensor, embedded sensor we use for that particular application. So next one, what are the embedded sensors? Are uh, why are the embedded sensors are important for IoT? So these are the some reasons: monitoring and controlling physical data continuously. That is the first advantage or application of embedded sensor. And predictive maintenance. Predictive maintenance, environmental monitoring, and user interaction with the device. So here, motion sensors in smartphones allow for gesture control, light. Sensors adjust to screen brightness based on the ambient light. Based on the environment light, just the screen brightness will be automatically, it will change. And monitoring and control, the smart thermostat uses temperature sensor to regulate room temperature, while wearable use motion sensors to track activity levels. So these are the some important points to need to know why the embedded sensors are used to develop the IoT real-time projects. So the benefits of embedded sensor here, miniaturization, small size allows for integration into compact of IoT device, and low power consumption. Many sensors are designated for low power use, crucial for battery power devices, and easy of use. Often require simple interfaces for connection to microcontroller within the IoT devices, and a variety of options. The vast range of sensor types caters to diverse sensing needs in IoT applications. So these are the some benefits of embedded sensor: miniaturization, low power consumption, low power consumption, easy of use, and variety of options. Variety of options. So these are the benefits of embedded sensors in IoT. And integration with microcontroller here. We have different points to explain. Embedded sensors can collect the microcontrollers and brain of the IoT device. These are microcontrollers can do the some specific tasks like these three: read the electrical signals from the sensor, the first point, and convert the signals into meaningful data using calibration factors and calculation, the second point. Process the data and make decision based on the sensor readings, the third one. Communicate the data to the cloud or other devices for the further analysis and control action. So these are the microcontrollers can do this integration with the microcontroller. And choose the right embedded sensors here. We have the some challenges here. What you are measuring, what is the required accuracy and range, power consumption, and limitations like environmental factors. Based on these factors, just we can choose the which embedded sensor is right for to using to develop the IoT real time projects, like that. You have to assume. And examples of embedded sensors here. a smart thermostat and wearable fitness tracker, smart agriculture systems, and smart homes and industrial IoT. So these are some real-time examples of embedded sensors in IoT. We use, for example, smart thermostat here. In order to record the data of temperature, humidity sensor for comfort control, that is the smart thermostat. Wearable fitness tracker, motion sensor, just an example, to track steps, heart rate, and temperature sensor, like that. And small agriculture, small match sensors, temperature sensors, a light sensor to optimize irrigation and crop health. So that is the third one. And motion sensors for security and occupancy detection, temperature sensors for thermostat, and leak sensor for water detection sensor. So these are the some examples of embedded sensors in IoT. And learning resources for this embedded sensor, just you can type in online embedded sensor with Arduino or sensor type for IoT project. Just you will find the various things like their applications, connection method, code, project ID. Not only with this, it displays so many IoT real-time projects. Just you may go through that to develop the any real-time IoT project. So these are the some learning resources for embedded sensors with Arduino. And distance measurement with ultrasonic sensor here. Certainly in the realm of Internet of Things, ultrasonic sensors offer a cost-effective, versatile solution for measuring distance. Here's a breakdown of how they work and their applications in IoT projects, and how to integrate them without microcontrollers. So ultrasonic distance measurement principle here. The principles are emission, sound emission, echo reflection, and time measurement. So these are the three ways of to distance measurement principle, based on the sound, based on the echo from these audio signals, and time measurements also just we can use. So with the help of this, calculating the distance of some distance to the speed of sound in air is known as value approximately 343 meters per second at room temperature. By dividing the round trip time by twice the speed of the sound, just we can calculate the distance of the project. And factors affecting the accuracy here: temperature, and object, material, sensor angle. So these are the factors to measure the exact accuracy of the device. So the temperature, the speed of sound varies with temperature. So calibration might be needed for high precision applications. And object material is nothing but highly absorbent materials like thick curtains might dampen the sound wave and affect accuracy. The sensor should be relatively perpendicular to the target object for accurate measurement. So these are the factors affecting the accuracy of the IoT device. So next factor affecting the accuracy: continuation, and temperature, object material, and sensor angle. So these are the remaining same. Next applications of IoT through based on this. Here, abstract detection, summary inventory management, liquid level management, smart parking, and security system. So these are the different applications just we are going to develop on the USB ultrasonic sensors. And integration with microcontroller, just how can we integrate with microcontroller, how can we dump the program onto the microcontroller here. Most ultrasonic sensors have a single simple digital or analog output. So here, by using digital sensors and analog sensor, the digital sensor is nothing but output is high signal when sound is emitted, and low signal when the echo is received. So the microcontroller measures the pulse width to determine the round trip time. And analog sensor, the output to a voltage signal proportional to the round trip time. The microcontroller converts the using voltage, the analog to digital converter before the calculating of the time. So the popular microcontroller platforms here, one of the Arduino and Arduino Uno and Raspberry Pi. So these are the my credit card size computers, mini computers, like two mini computer credit card size mini computer to do the variety of things, to develop the variety of applications in IoT. Arduino and Raspberry Pi very important. Offers libraries and tutorials specifically designed for ultrasonic sensor and integration. Raspberry Pi can be programmed with Python to interact with ultrasonic sensors. So these are the um, popular microcontroller platform Arduino Uno and Raspberry Pi. So next one, learning resources of Arduino ultrasonic sensor with just you can type online ultrasonic sensor with Arduino, ultrasonic sensor with Arduino and Raspberry Pi, very important. Just we already discussed in the last slide, and ultrasonic sensor for Raspberry Pi. Raspberry Pi. You will find some numerical tutorials explaining sensor connection method, code example for distance measurement, project ideas utilizing ultrasonic sensors in IoT application. Not only with this ultrasonic sensor, it can display many more real-time IoT projects also. Based on our requirement, just we may use which application we are going to develop based on the requirement. So here starter kits for microcontrollers often include ultrasonic sensors, providing a hands-on learning experience for working with distance measurement in IoT real-time projects. So these are the some learning resources on ultrasonic sensor with Arduino or ultrasonic sensor for Raspberry Pi. And by understanding ultrasonic sensor, their integration with microcontroller, you can create an IoT devices that perceives their surroundings and react based on the distance measurement. So these are the learning resources. So here on the ultrasonic sensor with Arduino, ultrasonic sensor for Raspberry Pi. That is open doors to various applications for enhanced automation, object detection, various applications like enhanced automation. Yeah, and the automation, just we have so many projects. Just the for example, coffee machine. When the coffee seeds going to end, so it automatically send the information the coffee beans going to end. Just you can immediately fill the box like that. The automation process will going on without any human intervention. The enhanced automation, so object detection. So any other person or another person came into our home, just it can automatically send the information to this particular destination. So another person is available at in front of our door. And uh, control exciting world of IoT. These are the three real-time applications of using ultrasonic sensors, automation, enhanced automation, object detection, and control existing world of Internet of Things. So these are the some learning points of USB sensors and embedded sensor, and last one ultrasonic sensor. So remaining question bank discussions and various things, we will continue with the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.